So sources of information. So this is something that you need to take into account when you are carrying out research. And we're going to look a little bit at some of the things that you need to take into account when you're carrying out research and you find like sources of information. So the learning outcomes for this lesson. So we're mainly going to focus on this learning outcome here. Students should be able to conduct research relevant to a scientific issue, evaluate different sources of information, including secondary data, understanding that a source may lack detail or show bias. So this is the main kind of learning outcome that we're going to focus on. The other two learning outcomes, we're going to touch on them very briefly in this lesson, but we will look at them in more detail in future lessons. So students should be able to evaluate how humans contribute to sustainability through the extraction, use, disposal, and recycling of material. So it's all about how we take materials, we mine materials and use them, we dispose of them. Sometimes we can recycle these materials. So it's looking at all of that. And the other one then is students should be able to research different energy sources, formulate and communicate an informed view of ways that current and future energy needs on Earth can be met. So this is something that's really important. So for example, like if you take, for example, we use electricity here in Ireland. So have you ever thought about how that electricity is actually generated? And sometimes we don't even think about it until maybe we go one day without electricity and we see like how reliant we are on a constant supply of electricity for everything that we do and use on a daily basis. But it's worth kind of thinking about how overall how the country, for example, generates its keeps up with that demand of electricity. And sometimes in most cases there that that source of electricity is linked to a material that's slowly running out. So that's something to kind of think about. So that's kind of like what we mean when we look at current and future energy needs. Okay, so if we take the materials life cycle. So if you look around the room that you're in now and think about everything, so the furniture, for example, the paint that's on the walls, and the glass that's in the windows, and then even if you look outside as well, you might see buildings and slates on roofs and things like that. So all of this stuff that is around us is made up of materials. And one common material that's everywhere that we rely on is copper. So this is copper. So it's the 29th element on the periodic table. So it has an atomic number, this number here on the top that's called the atomic number of 29. And it has a mass of 63.546. So this is its mass number. So 29, this number tells us the number of protons and electrons that's within this element of copper, within a particular atom of copper. And then this mass number is made up of the protons and neutrons. So that's just a little bit of revision in relation to the periodic table and elements on the periodic table. And then it has this chemical symbol. Now, copper is a material. This is kind of like what it looks like here. And it's a very useful material. Copper, for example, if you in your house, if you take all the plumbing in your house, it's more than likely going to be made up of copper pipes. So piping kind of like this. If you take, for example, all of the electrical leads, there's going to be copper in that, and the copper allows the transfer of electricity back and forth between like the plug in the wall, for example, and the device that's using the electricity. So they use copper wires. So copper is kind of it's like if you were to take a house, and there's a lot of copper inside a particular house. So there is. Now, all of these materials they have to be manufactured, but then also as well the materials have to be kind of produced. Okay, so where do the materials come from? So if we take copper as an example, so these are the stages. So there's 5 main stages in the development of most materials, and in this specific example we're going to look at copper. So stage 1 is the extraction of the raw material. So for example, if we take copper, there's mines where copper compounds that have copper in them are mined out of the ground. So they are. So you have mine production. Okay, so you have these mines that are where copper is extracted. It's heated up and smelted. Okay, so it's melted down and then it's refined as well. Okay, so they take this like copper, it's not pure copper, and what they do is they melt it down and then they can clean it up or refine it. So what you end up then is with pure copper in the refining stage. Then you have mills and foundries, and basically what they do is they can take this purified copper that's been extracted, and they move on to the next stage, which uh, is manufacture. So basically, what's going to happen is they're going to take this pure copper, they're going to in mills and foundries, and they're going to take that copper and they're going to manufacture useful materials that we can use. For example, if we're building a house or plumbing a house or doing the wiring on a house, so you get this manufacture. Okay, so the pure copper is turned into useful products like spools of copper that can be used in electrical work, piping, for example, and then like loads of other electrical work as well that copper can be used in. Okay, so what happens then is it's manufactured into these useful materials. So that's the manufacturing stage. Then the next stage then is distribution. So for example, these have to be sent from where they're manufactured out to the material suppliers in all of the different counties or countries in Ireland, like the different uh, providers all around the country. So, for example, you will have material suppliers that builders will go to buy, for example, copper off, or like electricians or plumbers. They will go to these suppliers and they'll buy the copper pipes, and the electricians will buy the copper wiring or whatever it is that they need. So that's the distribution stage. Then we have like the usage stage. That's where the material is going to be used. So, for example, the plumber will take the copper pipes, go to their building, put in the copper pipes. So that's the usage stage. And then maybe down the line, um, for example, if the house is demolished and they have to take out all of the piping, they'll strip the house and they'll get rid of or dispose of the copper. Okay, so they're the kind of main stages, if you like, of the material life cycle. So stage one is extracting the raw materials. Stage two is manufacturing, so taking the raw materials and manufacturing useful products out of it. Then it's distributing those useful products, and they could be distributed like from a central point in a country, like let's say China, and then they could be distributed to all countries all over the world. Stage four then is that the material is actually used, and then stage five is that once the material is no longer in use, and that can be from depending on what the product is, it's disposed of in some way. Now, this is a major, so this is a life cycle. It's it's absolutely necessary in order for us to live the lives that we live, and but this all takes energy, which is limited, and it impacts the environment as well. So, for example, to go through all of these stages, it takes a lot of energy. So, for example, when you're mining products, that takes an awful lot of energy that has to be supplied. It also impacts the environment. So, for example, you can pollute the environment and you can actually damage the environment when you're taking out these raw materials. When you're distributing, when you're manufacturing the products, so these foundries, for example, like huge amounts of electricity is generated to supply these manufacturing sites. And again, that electricity has to be produced, and it's normally produced by burning fossil fuels, which can pollute the environment. And then when it's used then as well, so think about like it has to be transported by ship maybe, and then by ship by lorry all around the country. And then when it's been used by individuals, so for example, to put copper into a house, it takes an awful lot of energy. Like they have to use generators to run pieces of equipment that are used to install, the copper pipe and the wiring, for example. So all of that is having an impact on the environment, and it's also using up limited sources of energy then as well. And then at the end then as well, maybe not so much with copper, but with, if you take, for example, like things like if you take a can of Coke, for example, the aluminium that's in a can of Coke, that has to go through the same process. And what happens then is that aluminium then has to be disposed of. So ideally what you want to do is you want to recycle it as opposed to just sending it straight into a dump into landfill. Okay, so you want to try and reuse it. Um, so this is the materials life cycle. So extraction of raw material, manufacturing, distribution then of the product, usage of the product, and then disposal of the product then as well. So again, is to think about this all uses up energy, and it has a massive impact on the environment. So take a minute to think about, and I'm going to get you to do a little bit of research on a particular product that has to go through all of these stages, and looking at all the different stages that it has to go through. So this is like how it is extracted, this is how it's manufactured, and there's a whole science then that goes into the extraction and the manufacturing of these products then as well. Now, like what I mentioned, there are these energy needs. So in order to do all of this, we have to generate energy, and that energy is generated in the form of electricity, and that electricity, it comes from the use of what are known as fossil fuels. So some of the main fossil fuels that we have are coal, gas, oil, and peat. So these are the main kind of fossil fuels that are used. And what can happen is that these can be used to uh, generate electricity. So in electricity generating plants, these are the main kind of ingredients that they use to generate electricity. And these are limited, so they're what are known as fossil fuels, and they're going to run out. So over time, these are going to run out. And not only are they going to run out, but when we use these fossil fuels, they actually pollute the environment. They basically contribute to what's known as global warming. So it's not ideal to be burning these and using these because like we have energy needs, we need to do all of this, for example, to keep society going, but we need to come up with a way to generate this energy that we need to carry out all of these functions, but to be able to do it in a way that's sustainable. So for example, these are limited resources. All of these materials have to be mined out of the ground as well, and when they're burnt, they're gone, they're used up, and eventually there's not going to be any more coal to be burned to generate electricity. So we have to come up with an alternative way to generate our energy needs. So energy is basically the ability to do work, and energy is needed in order to be able to carry out all of these functions. So some of the alternatives to using fossil fuels are to use sustainable sources of energy. So these are some of the sustainable sources of energy. So you have solar, so there's a huge amount of energy that hits the earth every single day through the sun. And what we can do is we can use these solar panels to absorb some of that energy and turn it into electricity, and then we can use that energy to do some useful work, like for example to to operate a smelting factory. We have hydroelectric, so this is basically where you're using a dam and you're building up a body of water, and then you're letting that body of water run down, and it turns a turbine, and that turbine turning generates electricity, and again then that can be used to do whatever useful work, like any of these particular things here that you want to do. That electricity can be used to do that. Here in Ireland, we use a lot of you can see like all across the country they're putting up wind farms. So you have these wind turbines, and the reason they're putting them up is because they can use the wind to turn this turbine. That turning of the turbine generates electricity, and then that electricity can be used to carry out some useful work, like power, like for example, power the electrical needs or supply the electrical needs that a house needs. Then we have tidal. So again, it's the same kind of concept except under the water. So if you take the beach, for example, tide goes in, tide goes out. As the tide is going in and going out, that movement of water can turn a turbine. That turning of the turbine then can be used to generate electricity. Um, Geothermal. So this is basically where so down underneath the ground, there's pockets of magma. Um, it gets very hot the further you go down under the ground, and that heat then can be used to generate steam, and then that steam can be used to turn a turbine and generate electricity. So that's what's known as geothermal. And then you have biomass. So instead of burning things like peat and oil and coal and gas that takes millions of years to generate, they can grow some kind of a product, some type of a crop that can grow very quickly, and then when you burn it, it generates electricity. So instead of burning this stuff, you can use biomass and burn some kind of biomass as well. So these are the old ways, well, they're the current ways that we use to generate electricity, and then these are the new, more futuristic, sustainable ways that we want to try and move towards in order to generate electricity. And again, this involves a huge amount of understanding and innovation from science in order for us to be able to do these kind of things. So when we're gathering information, we need to think about our sources of information. So for example, and you're going to carry out research, when we carry out an investigation, it is important to find out as much as you can about the topic before you start. This involves researching it using books, libraries, internet and media, such as newspapers, scientific magazines, or TV programs, or any other relevant source of information. So you have to get information. So these are all the different sources of information you can look at. But it's important to consider these sources when you're trying to inform yourself about a particular topic. So the different types of and the things that you need to kind of take into account when you're carrying out research then as well is, so primary data. Primary data is data that has been generated firsthand, that you've generated firsthand. So for example, if you have went out and measured the mass of a particular object on a balance in the lab, that is primary data, that data that you take. Secondary data then is like secondhand data. So you haven't generated the data, but you're using the data. So for example, you might read a report or an investigation of a student that done the same experiment as you did last year, and it will have the measurements that they did last year as well. So if you were to use that information, that's what's known as secondary data. So there you have primary and secondary data. Now, bias, when you look at data, humans can be biased. So bias shows, so what is bias basically? Bias is where the person that generates the information or the reports or basically the information, they show only one point of view, which is not fair. So basically it's what's called like bias, for example. So if I'm involved in an organization that wants to protect the environment, I'm only going to show like information, for example, um, that that basically shows how bad generating electricity is. So I won't, like, I might not look at it on a level from a level point of view where, well, okay, so we do, like, there is pollution to the environment, but it also generates electricity that supplies the electrical needs that we need to run hospitals and schools and carry out all the different things in society as well. And the other way it can happen the other way then as well, if I'm a big contractor and I want to build, for example, I want to build like a fracking, or like I want to mine like natural gases out of the ground, I'm only going to put, like, I'm only interested in getting that constructed so that I can carry out my manufacture and get the gas out of the ground. So I might like kind of not talk so much about like the impact that can have on the environment, and the information I might use might be biased. So this is something that you always need to take into account as well. When people talk to you about something, they'll generally give you their point of view, but that point of view is not necessarily a balanced point of view. So it's always important as a scientist to be balanced in relation to your ideas. And then you have like levels of detail. So again, depending on like so some sources of information are very detailed, and other sources of information, they might not give you all the detail that you need as well. And that can be a form of bias as well, where people leave out key details in relation to whatever it is information they're giving you. So a lot of information that you're going to gather will be gathered online on websites. So when you're looking at a website, these are some of the kind of things that you need to take into account when looking at a website. So you want to look at the author, like who generated, so the name of the author is the name of the author given, or who generated the information that's on the website. So that's a big one. Date, so the date is given for all research findings that are listed, and they're regularly revised as well. So when you get information from online, you want to check and see, is it up to date? Is it has been generated in the last year, or has it been generated like 10 years ago? The source of the information, so articles and websites, they give the source of the information presented, possibly with links to support them. so you can tell that the information is not just personal opinion. So you want to kind of think about like where does the information come from, and like what's its source? Does the person give the source of the information? The domain then relates to the website. So in general, websites from universities, so for example, they end in .edu, governments that end in .gov, and organizations such as BBC and NASA are more reliable. Some domains such as .com, .org, and .net can be purchased and used by individuals then as well. So websites are run, like generally ones that are run by organizations are more kind of, they generally tend to be more balanced and not as biased. So it's important to kind of take that into account when you're researching on websites. Site design. So again, it's good to look at the site and see a well-designed site can indicate a more reliable source. And writing style. So good grammar and spelling are an indication that the site may be credible as well. Okay, so these are kind of some of the things that these are some of the things to consider when you are finding information online and you're looking at the sources of the information. So as an example, so I went and done a little bit of research on how does Ireland generate its electricity, and like what materials do they use in order to generate their electricity. And this is a source of information that I got. So you can see that it's a graph, and the source of the information is the SEAI. So SEAI is Sustainable Energy Authority of Ireland. Okay, so they're a government body, so they're generally they're trustworthy. So this is the website source that I've put in here, and we can see that, like going through all of these individual sections here, that this is generally kind of it's a fairly trustworthy source of information. If we think about the type of data that it is, it's secondary data. I did not go and generate any of this data. I got the data that was already generated and I'm just using it. So it's secondary data or secondhand data. And this is just shown, for example, like how, so over since 2006 up to 2020, the sources of input to electrical generate. So basically like what our ESB are using to generate electricity in Ireland over since 2006 up to 2020. So if we have a look at this, so here is just, it's in kilotons of energy that's been produced. So we can see here that if we look at it, like gas, natural gas is the biggest, it's like this is the biggest source of electricity generation in Ireland. Okay, so using natural gas to burn to then turn a turbine, heat water and turn a turbine and generate electricity. So the next one then is coal. Okay, so we use coal then. The next one down then is peat, and then we use oil then, and then waste or non-renewables. It's fairly negligible or fairly small. But what we can see is over, and then we have renewables. Okay, so renewable sources of energy like wind. So what we can actually see is that we're starting to move in the right direction. So we can see that if we look at this yellow section here, these are renewables. So since 2006 up to 2010, we can see that the use of renewables to generate electricity is starting to increase. So it is, and that's good. That's what we want. So again, this is a source of information. This is just a way, and these are some of the things that you want to take into account when you're gathering your sources of information. So some of the resources of Ireland. So natural resources are things like land, gas reserves that are still in the ground, fish in the sea, and virgin forests as well. So these are what are known as natural resources. And you're going to be doing a little bit of research. You're going to identify some natural resource in Ireland, and you're going to identify like what's the science behind getting that getting, like, let's say like how do they extract that material, how do they use it, what's the science behind it. So this is like just one example of some of the natural gases that we use in Ireland. So here we can see, so these are some gas fields all around Ireland. So we've one here down near Cork in Kinsale. So there's been a lot of media coverage in relation to the extraction of gas from Kinsale from this source down here. So all around Ireland, for example, there's all these natural deposits, if you like, of natural gas and natural oils. So if we take the natural gas or natural oils, how do they extract them? So basically, they have to build oil rigs, and then what they do is they drill down into the ground and they drill down into the source of the gas or the oil. And then what they can do then is they can extract that material, that natural resource, out of the ground. And what they'll have is they'll have like oil rigs, something like this. And basically, what these oil rigs will do is they will purify and clean up they'll extract the natural resource from the ground, and then they will clean it up and tidy it up, and then they'll basically put it into massive containers, and then they're shipped off the oil rigs, and then they can go to refineries where they're refined further then as well. So these are like, this is just one particular natural resource, for example, natural gases, and how they are extracted out of the ground. So when you're doing your research, this is kind of like what we'll be getting you to do. Like, think about like how like, where does this natural resource come from? So these are like maps showing like where the resource comes from. How is it extracted? What's the science behind it? That type of thing. So this is kind of like how they do it. So when you're doing your investigation, these are always some of the kind of things to take into account when you're doing it as well. So investigating, you will choose a topic and a research question. So you're going to choose a particular topic in this case, and you're going to do some research on it. So find out and reference information from a number of balanced sources. So you're going to be going out to get information in relation to the topic. So you want to make sure that your sources are balanced and that like you're taking into account previously what we talked about. So find out and reference. So you always want to write down where you're getting your information from and include that in your report as well. Evaluate the reliability of the sources, okay, and consider the quality of information from the sources then as well. So when you're looking at websites, you want to consider the sources of this information. And this is a really useful way to do that. So evaluate the sources. So you've CAR or DSS, so cards. And so this is just an acronym that you can use, but when you're looking at the source of information, you can use this to evaluate the source of information. So C is credibility, A is accuracy, R is reliability, or the other R is relevance, D is date, S is source, and then S is this scope and the purpose. So when you get, let's say, your first information, so the first one is credibility. So who is the author? Who generated the information? Can you trust them? Like, if it's scientific information and it's produced by somebody that has no science qualifications at all, that's not very trustworthy. Okay, so that's the kind of thing that you need to take into account. A is accuracy. Can facts and statistics be verified? So can you actually, is it accurate, or did somebody just make up the information? Or is, does the source present bias? Okay, so or is reliability. Is the source biased? So have a look at it. Is it leaning towards one particular point of view, or is it given a balanced output? Uh, or then the other or is relevance. Does the information help to answer my question? So again, there's loads of information out there, but you're trying to see, is it relevant? Can I actually use this information? D then is so the date. When was the information created? So if it's really old, it might not be as accurate nowadays as it was back when it was generated. S then is the source. Did the author use reliable sources? So if you're taking secondary data, like where did that information come from? Is it reliable? And then the last one is scope and purpose. Does this source address my question in a comprehensive way? So for example, like the information that you're going to use from the internet, does it like help me in order to finish off my topic or my project? So these are the things, these are, when you're evaluating information, this is what you need to kind of take into account. Now, also as well, as you go along, you want to keep records of what you're doing. So keep ongoing research records. So when you're in the research phase, it's always a good idea to just keep a page and write down, for example, the sources of your information, and you'll use that then as a reference. So it doesn't have to be anything overly complicated. You can use something like a mind map, for example, and you can use this to plan out your project and also as well to keep a record of what you're recording. Or it can just be something like this, just simple, just like a heading and just bullet points in relation to the topic that you're looking at. Okay, so that was So sources of information and some of the things that you need to take into account when you're carrying out research and preparing projects. Okay, thank you for listening.